Hi, welcome back. It's Algebra 2. Today's lesson 2.9, zeros of polynomial functions. The zeros of a function is or are the values where the function crosses the x-axis. We call them zeros because it's where the function is equal to 0, or where f of x is equal to 0, or where y is equal to 0. So keep that in mind, y is equal to 0. They are sometimes referred to as roots as well. When we came into Common Core, for some reason, they decided to start calling them zeros. All right, but you will hear them referred to as roots once in a while. Also as x-intercepts. In this lesson, we will explore cubic and quartic functions, those whose highest powers are x to the third and x to the fourth powers respectively. We will spend extensive time on quadratic functions in a later unit. Okay, I'm having trouble reading today. It's been a long day. So here we go. Exercise 1. Now, for each of the following cubic functions, sketch the graph and circle its x-intercepts. So we're just going to simply put these into our calculator and get an idea about what they look like. Because when it says sketch them, it means we don't have to be exact. And that's why the graphs I gave you are not exact graphs with graph paper and the whole thing. So let's pull up our calculator and see what it looks like. So as we can see, we're hitting our zeros at -2, at 1, and at 4. So we're going to translate this now back to our worksheet, at least the best job that we can anyway. So it's going to look something like that. Not exactly, but this is a really bad arrow. So something like that, all right? So then it says to circle our zeros, and that's the important part. So here, here, and here are going to be our zeros. So we're going to do the same thing with B and C. So again, I'm going to pull up that calculator and show you what it looks like once we've put it into the calculator. Obviously, you can't do this at home, so we can practice this once you come back to class. So this is what B looks like on our calculator. As you can see, it only has one root, and it falls somewhere between -2 and -3. So let's give that a quick translate onto our worksheet. So it looks something like that. So one more time, we're going to circle our x-intercept, which is right here. And one last time, we're going to do this with C. So here's the calculator. And now we're going to try and translate this onto our paper the best that we can. So we have a root at 0 here, and we have a root at 3. So here we go. So something like that is what it should look like. And like I said, we're just sketching here. So what do we notice about these three? Let's see, in this case, we have 3 roots here, or zeros. We should call them zeros, right? We have 1 0 here, and we have 2 zeros here. So I think what we've learned here is that in a situation where we have a degree 3 or a cubic, we can have 3 roots, we can have 2 roots, or we can have 1 root. I don't think there's any possible way to get 0 roots because at any given time you do have to cross that x-axis. All right, so that's what we came away with exercise 1. So now let's take a look at exercise 2. So I'm sorry, we have a little bit of a problem here on this page. On your page, you can see pretty easily, it says consider the cubic whose equation is, and then A says algebraically determine the zeros of the function, and B says sketch a graph of the function on the axis illustrating your answer to part A. And for some reason, these two merged. So what we're going to do is the same thing we did before, is we're going to throw this. Now this says to do it algebraically, so you could throw it into your calculator, but if it says to do it algebraically, we really should. So we have the x cubed, I'm going to bring it over here, minus x squared minus 12x. And the first thing you're going to do is think back to all those factoring lessons that we did. The first thing we're going to do is factor out that GCF, which is an x, and get x squared minus x minus 12. And then simply we can factor this one more time into x minus 4 and x plus 3. So when we solve these, hopefully you remember, you have to set each of these products equal to 0. Our zero product law tells us this. And solve. Now I think by the time you hit algebra 2, you realize that if your factor is x minus 4, then your 0 is x equals 4. And if your factor is x plus 3, your root is x equals negative 3. So negative 3, 1, 2, 3, 4, and 0. And what this looks like is it kind of increases, it decreases, and then it increases again. Again, when it says to sketch it, it means you don't have to be exact. I have to make sure I change that. All right, so moving on to exercise 3. The largest root of this mess falls between what two consecutive integers? Well, this is the easiest question in the whole world, because as long as you have that beautiful piece of technology on your desk, we can open up our calculator and we can put it in here and get an answer. So we open up our calculator and we're going to put this in here. So we're going to do x raised to the third power minus 9x squared plus 12x plus 22. Obviously, we're not going to put the equal 0 in there. We have our equals already, and we're going to hit enter. And this is going to hit in a couple of places. It looks like it hits exactly at negative 1, and then it hits between 3 and 4, and then again between 1, 2, 3, 4, 5, 6, and 7. So let's go back to our question here, and it says which is the largest root, and we know that falls between 6 and 7. So that was a 2-point question, like just handed to you. Just knowing if you know how to use your calculator, you know how to answer that question. All right, so exercise 4 says consider the quartic function y equals x to the fourth minus 5x squared plus 4. It says algebraically determine the x-intercepts of this function. Well, algebraically means we should be able to factor this. So let's go back to what we remember about factoring. The first term is going to have an x squared in it. And because it looks like a trinomial, we know we can kind of follow the same rules as a trinomial. So we need two numbers that multiply to 4 but add to give me 5. So we know it's going to be minus 4 and minus 1. So then we can factor this one more time, because these are difference of perfect squares. Hopefully those red flags are going off. So we have x minus 2, x plus 2, x minus 1, x plus 1. Now, we still haven't found the x-intercepts, because now we have to realize that our x-intercepts are going to be our zeros here. So we have positive 2, negative 2, positive 1, and negative 1. So positive 2, negative 2, positive 1, and negative 1. And if you put this into your calculator, which I already have, you have an intercept that looks something like this, a function. It kind of looks like a W, something that looks like that. These should be closer to the same. So let's see if I'm going to be a little bit picky about this. It should look more like that. Well, again, pretty much, except for knowing how to factor, that was a pretty easy question to do. And let's look at our exercise 5, which is our last one for this lesson. All right, so consider the quartic whose equation is this right here. Sketch a graph of this quartic on the axis below and label its x-intercepts. So one more time, I've already done this. It's not so bad. This one actually has zeros at -5 and +5, and I think at 1, maybe 1 or 2. So it looks, yes, it's +1 and -1. So this one looks something like, and I think up here is somewhere close to 70. So this one looks like a W as well. So it looks something like this. Again, you're going to get this all off your calculator. And this is based on your graph in part A. Write the expression in its factored form. So now we can use the information we get from our calculator to find out what the factored form is. So we know our roots were +5, -5, -1, +1, and +5. So what does that look like in factored form? Well, x plus 5, x plus 1, x minus 1, and x minus 5. So whenever they ask you for the roots of a function and they tell you to do it algebraically, you can always cheat just a little bit. Go to your calculator, graph it, and see what the roots are based on what your calculator tells you, and then kind of work it backwards. All right, we'll touch base with that again when we hit polynomials, quadratics and parabolas. All right, because I'm going to show you how to back into the answer if by chance you're not able to factor it. But hopefully with all the factoring practice we've done, you guys are going to be master factorers, if that's even a word. All right, so kept this video under 13 minutes, which is even better than before. And until I see you again, make sure you keep doing that homework, keep practicing your math, because it's just going to make you stronger algebra students. Okay? As always, make good choices.